This is CPM Calculus Chapter 4, number 41. So what if our function f of t is not a constant function? Examine the area function a of x of a line with slope of m not equal to 0. So it's not going to be a horizontal line, it's going to have a slope, right? So here's the example. F of t is equal to 4t plus 5. Alright, and we know that 5 is the y-intercept because it's in the form of y equals mx plus b, and 4 is the slope, right? Since our variable is t here, this is the t-axis, the x-axis is the t-axis, and our y-axis here is just the y-axis, or you can call it f of t, either way. Alright, and we know that our function has a y-intercept at 5 and a slope of 4. So it goes up 4 over 1, right? Up 4 over 1. I'm going to make 5 a little lower. So up 4 over 1, that would make it here, right? That would be 9, 1. And then we can connect these points, and there's our graph. That's our line, okay? All right, and we know that a of x means the area starting at 0 and going all the way to some value of x. It's the area between 0 and x under the curve, right? This is the same thing as a of the area between our function f and starting at 0, well, from t, right, because we have t as our x-axis, to x. All right, so let's evaluate the area function at 2. So a of 2, we know that's equal to the integral from 0 to 2 of our function dt. And what you have to notice for this problem is, what is this shape here that we're creating? This right here is a trapezoid, right? The area of a trapezoid, we know, I'll just write here, area of a trapezoid is equal to 1/2 base 1 plus base 2 times height, right? Where the height is the distance between the two parallel sides, and those two parallel sides are the bases. All right, so here we have this is equal to then 1/2 base 1. Well, what is the height at x, or t is 0? So if we plug in t is 0 here, we get 4 times 0 plus 5. And so that's equal to 5 because 4 times 0 is 0. So that's base 1. Base 2 is then on this side, we're going to t being 2. So if you plug in 2 here, you get 4 times 2 is 8. 8 plus 5 is 13. Okay, so that's the base number 2. And the height is the distance between 0 and 2. So 2 minus 0 is 2. So that is the height. Okay, so this again is a trapezoid. It's exactly the area of a trapezoid then. So then we could go ahead and multiply this out. In the parentheses here, we have 18. 18 times 1/2 is 9. 9 times 2 is 18. So this is 18 units squared. Okay, let's go on to part B. Part B is asking us to evaluate the area from 0 to 9 under this function. Now we're going from 0 to 9. It's still going to have the shape of a trapezoid. So it's going to be 1/2 times the base at 0. We knew when we plug in 0 into t, we get 4 times 0 plus 5 is 5. Plus we plug in 9 into t, we get 9 times 4 is 36, plus 5 is 41, times the height is the distance between 0 and 9, and that's 9, right? So we can simplify that. 5 plus 41 is 46, times 9. Half of 46 is 23, times 9. right? And 23 times 9, I'm going to bring out my calculator. 23 times 9 is 207. Okay, so that's equal to 207. And the area again is units squared. So there, we're done with part B. So part C says, well, what if you're just given that the other boundary is x? So you start at 0 and you stop at x. So that would be the function a of x. Okay, so that's exactly what we have drawn in our picture here. Right, we're stopping at x here. We're starting at 0. So what is the height? Well, the shape is still a trapezoid, right? But what is the height at this side? The base of the trapezoid here. So the area is going to be 1/2 times base 1, same formula. Base 1, you plug in 0 into the equation, so 0 times 4 here plus 5 is just 5. Plus, what's the height here? Well, when you plug in x into that t, you get 4x plus 5, right? And what's the distance between 0 and x? Well, that's just the length of x, right? So you can simplify this. That's 1/2. 5 and 5 combined, so it's 4x plus 10 times x. And that's equal to, you can distribute that half, 2x plus 5 times x, which is equal to, distribute the x, 2x squared plus 5x. Okay? And again, it's unit squared, but I'm not used to writing it unless we have a number that we computed, a numeric answer. But you can still write it, so I'm going to write unit squared. Part D asks, this should be x here. Let me use blue. So part D says, what does the integral from 0 to x 4t plus 5 dt compute? Well, we know that this is just computing the area under the curve from 0 to x. This is the same thing as the area under our curve 4t plus 5 between 0 and x, right? You can even write this in a sentence. This computes the area between our line and the x-axis between 0 and x. Or you could say within the region, same thing, 0 to x. Alright. Finally, we're asked to generalize the area, which is the integral from 0 to x of some generic line, right? This is mx plus b. We're using the variable t, so it's mt plus b. Okay, then we're asked, what is the significance of mt plus b? So when we have a general line, right, we know that b is the y-intercept. So whatever it looks like, the line, similar to this line here, right, b was the y-intercept, so that created the height at t is equal to 0. Right, so it's still going to be in the shape. This is going to create the area underneath a trapezoid, right? So it's going to be 1/2 times, and what is the height at t is equal to 0? Well, it's just m times 0 becomes 0 plus b, so it's b, plus what's the height when we plug in x into t? Well, that's just mx plus b, right? If we're plugging x into t, we get mx plus b. We're using variables, so that's what we get. Times the distance between 0 and x is the height of our trapezoid. So x minus 0 is just x. And this is the general form of our integral from 0 to x of a line. So let's go ahead and simplify this. We get 1/2. In parentheses, we have 2b plus mx times x. Let's distribute the 1/2. 1/2 times 2 here is just b. 1/2 times nx is plus 1/2 mx. We have times x here, so let's distribute that x, and we get bx plus 1/2 mx squared. Alright? Right, so that is the general form for the area of x where our function is a line. Okay? So what is the significance of mt plus b? Well, this is just, the significance is this is a line, right? It's the equation of a line, and we know that where m is the slope and b is the y-intercept. All right? And so we know one point for sure on our line is 0, comma b, because that is the y-intercept. Okay, so this ends for us CPM Calculus Chapter 4, number 41.